Hello viewers, today I am going to solve one example from GATE 2010 examination from the topic flow through pipes. So first we will see the problem statement. So this question or this example was asked for 2 marks. So first we will see the problem statement. A smooth pipe of diameter 200 mm carries water. So this is the pipe, you can see here, this is the pipe. The diameter of the pipe is 200 mm and it carries water. The pressure in the pipe at section S1 is 50 kilopascal. So this is section S1 and the pressure at the section S1 is 50 kilopascal. At the same time they have given elevation, that is 10 meter. So the elevation of this section S1 from the datum is 10 meter. At section S2 the pressure is 20 kilopascal. So this is the section S2, you can see here, and the pressure at the section S2 is 20 kilopascal. Elevation for section S2 is 12 meter. So here the elevation for section S1 is 10 meter and the elevation for the section S2 is 12 meter. And velocity is 2 meter per second. So the velocity of the flowing fluid is 2 meter per second. Density of water is 1000 kg per meter cube and acceleration due to gravity, that is g, is 9.81 meter per second square. So the question is, which of the following is true? So they have given 4 statements and we have to find out which statement is true. So statement A, flow is from S1 to S2 and head loss is 0.53 meter. So fluid is flowing from S1 to S2 and the head loss is 0.3 meter. Statement B, flow is from S2 to S1 and head loss is 0.53 meter. C, flow is from S1 to S2 and head loss is 1.06 meter. And D, flow is from S1 to S2 and head loss is 1.06 meter. So in this problem we need to find out, first we need to find out is flowing from S1 to S2 or S2 to S1. That is the first thing. And the second thing, we have to find out, or we need to determine, we need to calculate the head loss between these 2 sections. Yes. So now we will go for the solution. So first we will go for the given data. So given data I have divided in 2 parts, that is what, at section S1 and S2. So at section S1 diameter is 200 mm. So obviously that becomes what, 0.2 meter. This is the constant diameter or uniform diameter pipe. So the diameter at section S2 is also what, the 0.2 meter. Second thing, the elevation at section S1 is 10 meter. So here I have written Z1 is 10 meter. Elevation at section S2 is 12 meter. So Z2 is 12 meter. So pressure at section S1 is 50 kilopascal. So you can see here at section S1 pressure P1 equals to 50 kilopascal and that is nothing but what, 50,000 pascal or 50 into 10 raised to 3 pascal or Newton per meter square. The pressure at section S2 is 20 kilopascal. So you can see here 20 kilopascal and that is nothing but what, 20,000 pascal or 20 into 10 raised to 3 Newton per meter square. So pascal is nothing but what, Newton per meter square. Again this pipe is uniform diameter pipe, constant diameter pipe. So therefore the velocity at section S1 is equals to the velocity at section S2. So velocity they have given, that is 2 meter per second V1. So obviously the velocity at section S2 should be what, 2 meter per second. So V1 equals to V2, and that is nothing but what, 2 meter per second. Again, in the problem they have mentioned the density of the water, that is 1000 kg per meter cube, and acceleration due to gravity is 9.81 meter per second square. So this is the given data in the problem. Now we'll go for the solution. Yes. So this is the diagram. Yes. The pressure at section S1 is 50 kilopascal and pressure at section S2 is 20 kilopascal. So when we focus on this pressure difference between the two sections, that is S1 and S2, so pressure at section S1 is greater than pressure at section S2. So we can say that the possible flow is from S1 to S2 when we decide the direction of a flow on the basis of pressure difference. So pressure at section S1 is greater than pressure at section S2. So obviously the possible flow will be what? S1 to S2. But at the same time, potential, when we observe the potential head at section S1 and S2, we can see that the potential head at section S2 is greater than the potential head at section S1. So possible flow on the basis of potential head difference, the possible flow will be what? S2 to S1. So on the basis of pressure head difference, the possible flow will be S1 to S2. And on the basis of potential head difference, the possible flow will be what? S2 to S1. So here the question arises whether the fluid is flowing from S1 to S2 or S2 to S1. And the answer of this question is what? Fluid always flows from the section at higher total energy or higher total head to section at a lower total energy or lower total head. So to decide the direction of flow, we need to calculate the total head or total energy available at each section. So based upon the total energy available at two sections, we can decide the direction of flow. So total energy at section is equals to pressure head or energy plus kinetic head or energy plus potential head or potential energy. So addition of these three heads or energies is nothing but what? Total energy available at the section. So we need to calculate first the total energy available at each sections. So the formula for this one is what? Total energy is equals to pressure head is P upon rho g, kinetic head is V square upon 2g, and potential head is Z. So by using this formula, we can calculate the total energy or total head available at each sections. So first we will go for what? The total energy available at section S1. Yes. So H1 is the total head available at section S1. That is nothing but what? P upon rho g, that is the pressure head available at section S1, plus V1 square upon 2g, that is the kinetic head available at section S1, plus Z1. Z1 is the potential head available at section S1. So to calculate this one, section S1, P1 is 50 kilopascal, that is what? 50,000 or 15 to 10 raised to 3, divided by rho g. Rho is 1000 kg per meter cube, so 1000, g is 9.81, plus V1 square upon 2g, so V1 is 2 meter per second, so 2 square upon 2 into 9.81, plus Z1, that is what? The elevation or the potential head available at section 1 or S1 is 10 meter, so plus 10. So when we calculate this one, so we'll get the answer H1 is 15.29 meter. So total head available at section S1 is 15.29 meter. Now we will go for total head or total energy available at section S2. So total head available at section S2, that is H2 equals to P2 upon rho g, that is the pressure head available at section 2 S2, plus V2 square upon 2g, that is kinetic head available at section S2, plus Z2 is the potential energy or potential head available at section S2. So as per the given data, H2 equals to P2 is here, P2 is 20 kilopascal, that is 20 into 10 raised to 3 Pascal, divided by rho is 1000 into 9.81, that is G, plus V2 square upon 2G. So V2 is 2 square upon 2 into 9.81, plus Z2 is 12. So when we calculate this, so we will get H2 equals to 14.23 meter, that is the total head available at section S2. And earlier we have calculated H1, that is what, 15.29 meter, that is the total head available at section S1. So when we observe these two, we can say that the total head available or total energy available at section S1 is greater than total head available at section S2. So we can conclude that net head or total head at section S1 is greater than net head or total energy at section S2. So the flow direction is from S1 to S2. Now we want to find out head loss between the section S1 and S2. So obviously the total head loss between the section S1 and S2 is what? H1 minus H2. So H1 we have already calculated, as well as H2 we have calculated, and that total head loss between the two section is 15.29 minus 14.23, and that is nothing but what? 1.06 meter. So already we have seen these options or these four statements and the correct state. So the option C, in option C the head loss is 1.06 meter and the flow is from S1 to S2. So the answer is C, that is what? Flow is from S1 to S2 and the head loss between the two sections is 1.06 meter. So answer is C. So thank you for watching this video.